In this video, I'm going to explain about some of the basic concepts about memory. Any computer science student, whether irrespective of the branches or the allied branches of the computer science, so every computer science student should know about this concept of this memory. See, many people simply know about the memory, but how it works or how the data is going to store, how the data is transferred, that most of the people don't know, and it is not covered in any one of the textbooks. Okay, so it is this knowledge is combined, you will get only after getting some 3 to 4 different subjects. Okay, so that I'm going to explain in this video. I'm making it simple for you people. Okay, we know that. So every computer system should have some memory. Okay, and memory is broadly categorized into 2 types that also everybody know that. One is what? Primary memory, and another one is what? Secondary memory. This primary memory is also called as what? Main memory. Right. So another one is secondary memory or disk memory or whatever you say. So what is meant by secondary memory? Or we call external memory. So from external, whatever the memory devices we are connecting externally to our system, all comes under secondary memory. For example, your CD, externally we are connecting, DVD, externally we are connecting, pen drives, it is called USBs, so that is also externally we are connecting. So then memory cards, that also externally we are inserting, floppy disk, hard disk, all these are comes under the secondary memory. Then what about this primary memory? Again, this primary memory again broadly categorized into, so one is RAM, and another one is read-only memory. Okay, so again, primary memory, also called as main memories, of 2 types: RAM and read-only memory access. RAM stands for random access memory. This is read-only memory. As the name itself indicates, read-only memory means from that memory I can only read, I can only take, I can only fetch the data. Only I can read. I cannot give the data into that memory. We cannot store our own data into that memory. That means we cannot write on that memory. So that's why it is called read-only memory. The name itself explains. From that memory we can only read. So we have nothing to do with that read-only memory, because we cannot do anything, our own operations. We cannot write anything, we cannot change anything. So whatever it is already there in that memory, that only I can read it. So nothing to do that. So we are going to study only about the RAM. Okay, that's what random access memory. What do you mean by random access memory? Suppose my memory is like that. So always our memory is divided into blocks. Okay, our memory is divided into blocks. So, okay, in one block I can store 1 byte. Okay, so this is my one block, or I can say one location. In one location I can store 1 byte. 1 byte means what? 8 bits. Group of 8 bits is equal to 1 byte. So in one block or in one location I can store only 1 byte. That means 8 bit. So in order to identify each memory locations, we are assigned unique addresses to each locations. For example, suppose my memory is 16-bit address memory, for example. So then 0, 0, 0, 1, 2, 3, 4. Okay, like this, all zeros. So next memory location, this is 1. Like this, next memory location, like this it goes on, memory addresses. So this is the memory addresses. To identify each locations of the main memory, one address is assigned to identify. See how we are using the names to identify the persons. How we can call upon individuals by the names. Similarly, how I can identify individual memory locations by the addresses. Okay, so this is what the memory is. Okay, now why it is called random access memory? Assume I am coming from here. So assume what is the time taken to access the data from here, because this first memory we can say is easy, right? First, but second memory same time, third little bit more time, fourth little bit more time. So as we go, so how many locations are there? Assume, suppose you know that in your mobile. So generally now if people are using what? 8 GB RAM, right? You are saying 8 GB RAM. What do you mean by 8 GB? So 8 means 8. Then into G means 10 to the power of 9. That means 8 followed by 9 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9. These many locations will be there like this. These many locations. See how to identify these locations. So for every location, one address is assigned. Okay. So now Accessing always, first one is very easy. Assume there will be line like this. In the line, 100 students are standing. So I want to distribute the question papers. Suppose giving first question paper to the first student is very easy because very near to me. So it will take hardly some within my milliseconds I can give. But second student in the line, so for that I will get little bit more, not that much difference. But fifth person, so again it will take little bit more time when come to the first person. So for 100%, so it will not too much of time. So like that, see these many locations are the crores of locations will be there. So obviously time taken to get the data from each and every location same. Yes, same. Whether you take the data from the first location, whether you take the data from the 100th location, whether you take the data from the 1000 location, whether you take the data from the 1 crore location, wherever you can take, irrespective of the order, that means randomly you pick any location, time taken will be the same. So that's what the random access memory is called. Okay, this is what random access memory. Now let's discuss some other things. Okay, now we know that we users, okay, always we are storing all our data or program or files where, that means we user, where we are storing. Assume we got some new movie we got. Okay, we are storing anywhere in some C drive, D drive, E drive. Okay, hard disk we are storing. Suppose we got a new game. Okay, that also we are storing in the hard disk. Okay, that is secondary memory. That means everything we are storing in the secondary memory. That means we user always store in what? Secondary memory. Whatever the movies, whatever the songs, whatever the games, or whatever the PPTs, whatever the PDF files, or whatever the notes, or whatever we are getting, that we are storing in what? This one. Whenever we want to take, we are taking from here only. We user. Okay, but we know that whenever we are taking in, whenever we want to execute anything, that should be in what? Main memory. And we know that who is responsible for doing everything? We know that what? CPU. That means central processing unit. So this is also called as a processor, microprocessor, RSM. So the CPU is responsible for performing all the operations. Okay, everything will be done by CPU only. Okay, now whenever, assume I got this one, assume this is one movie I got, new movie, I want to watch this movie now. Now this is stored in where? Secondary memory, I stored here. But who has to play this one? Processor. But we can store only in the secondary memory. We cannot store anything in the main memory. No, user cannot access main memory. Either user cannot take from the main memory or user cannot store anything into the main memory. Okay, then whose for main memory is CPU can take only from what? CPU can take only from main memory, or CPU can give data to the main memory. That means CPU can access. Access means taking, giving both. Okay, CPU can access only main memory. CPU cannot access what? Secondary memory. Similarly, user cannot access main memory. User can access only what? Secondary memory. Now, but I want to execute this file. But who has to execute? This person has to. CPU has to execute. But CPU cannot take from secondary memory. So what to do? Whatever the file we want to execute, that file, first of all, we need to bring it to what? The main memory. So that program we need to, from the secondary memory, we need to bring it to what? Main memory. Now the question is, who is going to do that operation? Okay, so whatever the files which are in the secondary memory, whenever we want to execute, that should be in the main memory. Why? Because from main memory CPU can take, and CPU is performing all the operations. Okay, so who is bringing from secondary memory to main memory? That will be done by your operating system. Whichever the operating system you have installed in your system, that operating system is responsible for transferring all the data and files from the secondary memory to the main memory. Once operating system brings this file to the main memory, now CPU can take instruction wise, only one by one, not entire program. Why? Because CPU inside this contains what? ALU, control unit, and some set of registers. See, these registers are the fastest memory, slower, and then the smallest memory, costliest memory. Okay, these registers can store only in terms of bits. either 32-bit, 64-bit, like that it can store. So it cannot bring the entire your MB's file size or GB file size. It cannot bring. Okay, so it will bring only some instructions. Then you keep it in registers, execute. See, whenever you open any file, it takes some time, some circling, buffering, it will take, right? Why? Because it takes time to bring that file from secondary memory to main memory, and from main memory to CPU it has to take. For that time only it will take the time. So once CPU reads this and then it will execute, assume after doing operation, again it will store back into the main memory. And once it is done, suppose then whenever we saved, again this will be again from the main memory, again it will be goes back to the secondary memory again by your operating system. So operating system is responsible for transferring the data between secondary memory and the main memory. Okay, so this is the very basic concept you should know. If you know this concept, then this subject of computer organization is very easy, and the same concept you need in one more subject called operating system. So this is you are going to study in your 4th or 5th semester, one subject operating system. But now for computer organization, so in order to start with, we need this concept. Hope you people understood. Now the summary is what? User cannot access main memory. User can access only what? Secondary memory. Similarly, CPU cannot access secondary memory. CPU can take only from the main memory. Now, whatever the data we are storing, so that we are storing in only secondary memory. But whenever you click on play or start or whatever you want to open the file, close the file, everything will be done by what? CPU. So in order to execute any file, that file should be in the main memory. And so, but why? Because once it brings to a main memory, then CPU can take. So who is bringing from secondary to main memory, secondary memory to main memory? Operating system is bringing. Once operating system brings, CPU can take and execute. Okay, this is the just basic concepts of the memory. So hope you people understood. If you have any questions, please write it in the comments. Thank you. Thanks for watching.